Mr. Burgeon, hire the calculus guy.
Mr. Burgeon, hire the calculus guy.
Mr. Burgeon, hire the calculus guy.
Calculus rules.
Mr. Burgeon, hire the calculus guy.
Calculus has something to do with math.
Mr. Burgeon, hire the calculus guy.
16 minus 7 is 4.
Mr. Burgeon, hire the calculus guy.
This video has three main parts. First, I'm going to ask you to copy down the derivatives of trig functions. Second, we're going to review how to rewrite some trig functions in terms of sine, cosine, and tangent. And third, we're going to look at three examples of how to evaluate derivatives of trig functions. And remember, you can't spell trig functions without fun. In an effort to keep this video as short as possible, I'll ask that you pause the video right now and record these derivatives of trigonometric functions. After you'd finished copying these down, resume the video. In addition to knowing these 6 trig functions, you'll also need to remember how to evaluate cosecant, secant, and cotangent of x. So we'll review that here. If you're trying to evaluate a cosecant of x function, you can really evaluate this using 1 divided by sine x. If you're trying to evaluate secant x, it's much easier to evaluate this using 1 over cosine of x. And if you're trying to evaluate cotangent of x, it'll be a lot easier to evaluate 1 over tangent of x. And the reason why it's easier is these functions, sine, cosine, and tangent, are available in your graphing calculator, whereas cosecant, secant, and cotangent are not. Now let's do some examples where we use these derivatives of trigonometric functions. The first one says, if g of x is equal to cotangent x, what would g prime of pi over 4 be equal to? So first we'll need to find our derivative of g of x, g prime of x. We'll look at our chart and say the derivative of cotangent of x is negative cosecant squared x. Then we'll need to substitute in pi over 4 in order to evaluate g prime of pi over 4, which will be negative cosecant squared pi over 4. This is quite difficult to evaluate using a calculator, so it's much easier to rewrite this as negative 1 over sine squared pi over 4. Then what negative 1 over sine squared pi over 4 really means is negative 1 over sine pi over 4 times 1 over sine pi over 4. And you can multiply these together and get a solution. In this case, the answer comes out to negative 2. If you're evaluating this and you're not coming up with negative 2, first check to make sure that your calculator is in radian mode. Let's try another example. It says g of x equals tangent of x, and it wants us to evaluate g prime of pi over 4. We'll start by evaluating what g prime of x is, and g prime of x, or the derivative of tangent of x, is secant squared x. So we'll write that over here. Secant squared x can be a little difficult for us to evaluate, so we're going to rewrite this using the rules we learned in the beginning of this video, where it says secant squared x is really the same as 1 over cosine squared x. Then it'll be quite easy for us to plug this into our calculator to figure out pi over 4. So we're going to plug in 1 over cosine squared pi over 4. This can be a little tricky to evaluate, so I really do prefer this to separate this into 2 separate equations. It's 1 over cosine pi over 4 times cosine pi over 4 if you want to do it that way, or you can just multiply by another 1 over cosine pi over 4. There are 2 cosine pi over 4s, and the bottom of this fraction is what we're getting at. Once you evaluate this correctly, you'll end up with answer of 2. Let's look at one more example, and let's find g prime of 3 pi over 4 if g of x is equal to secant x. First, we'll find our derivative of secant x, g prime of x, consulting our chart, and we'll see the derivative of secant x is secant x times tangent x. Secant x can be a little tricky to evaluate, so let's go ahead and rewrite this as 1 over cosine x times tangent x. Then we can evaluate g prime of 3 pi over 4 by substituting 3 pi over 4 in for all the x's in this equation. You can use any method you want to evaluate this. You can use the unit circle, graphing calculator, or another resource, but I always use the calculator for these. When you multiply these together, you get what it looks like approximately 1.41. This option will not be available in Khan Academy, but when you do see the options, you'll see that 1.41 is very close to, and in this case, the exact answer here we're looking for is square root of 2.